Vercel acts as the underlying engine of the modern internet. They host the front-end infrastructure for massive tech platforms, startups, and decentralized crypto exchanges. If you use a web application today, it's highly probable your traffic flows through their servers. On the morning of April 19, 2026, development teams woke up to a crisis. Crypto engineers and web developers across the industry began scrambling to freeze their deployments and secure their systems. A massive database of Vercel API access tokens and source code appeared for sale on a cybercrime forum. The asking price was $2 million. Soon after, Vercel CEO Guillermo Rauch released an official statement confirming the threat. An unauthorized actor had indeed gained access to Vercel's internal environments. But the incident response teams quickly noticed something strange. Vercel is known for having some of the tightest perimeter security in the industry. Yet their external firewalls hadn't triggered any alarms. The attackers didn't need to break through the front door. They had bypassed the perimeter entirely, entering through a blind spot that traditional cybersecurity defenses were never built to monitor. To find the actual entry point, investigators had to look away from Vercel's servers and examine a seemingly harmless productivity app called context.ai. A cybercrime syndicate known as Shiny Hunters had successfully breached context.ai's internal systems, and unfortunately, a Vercel employee had connected their workspace to the tool. This access was powered by OAuth, the technology that lets you log in with Google to connect apps to your workspace. This signature allowed the hackers to mask themselves as the employee. They inherited the same permissions, granting them immediate entry into the employee's corporate Google workspace, including their internal emails and Google Drive. In an interconnected software world, a convenience tool adopted by a single employee acts as a direct, unmonitored bridge straight into a company's core infrastructure. From the employee's emails, Shiny Hunters moved deeper. They used the stolen identity to pivot from the workspace environment into Vercel's internal developer systems. This gave them access to environment variables. Think of these as the specific authentication strings that a front-end website uses to talk to its back-end databases and payment processors. Vercel has a system to encrypt these variables at rest, but it relied on a checkbox marked sensitive. In a fatal design choice, this feature was an opt-in toggle, meaning it was turned off by default. Any credential left unmarked by a developer was sitting in plain text. The hackers began extracting thousands of unencrypted database connection strings, Stripe payment keys, and GitHub access tokens. By prioritizing a frictionless developer experience over mandatory security constraints, Vercel had inadvertently weaponized a single compromised identity into a systemic crisis. The immediate fallout was an operational nightmare. Incident response playbooks instructed thousands of Vercel customers to completely freeze their production deployments and sever their automated GitHub connections. Engineering teams were forced into a massive logistics race. They had to simultaneously invalidate every exposed credential and reissue new ones across their entire stack before the hackers could use the stolen data to move even deeper. The Vercel hack was just one strike in a broader campaign by Shiny Hunters. They have spent years refining this tactic, using compromised third-party integrations to hit massive platforms like Snowflake, Salesforce, and Okta. This tactic has become the preferred path for modern intruders. Identity hijacking is significantly quieter and more efficient than trying to brute force a corporate firewall. A multi-billion-dollar platform security no longer lives or dies at its own corporate gateway. It is now entirely dependent on the security standards of the smallest, most obscure third-party integration they have authorized.